Okay, so what do you guys want to do now? More scenarios? See, the funny thing is at the end of the semester, sometimes you guys are like, oh, I can't remember anything about the computer. And sometimes you're like, no, scenarios, that's it. So we should do a mix, but yes.
B3.
B3, we got a specific one.
We just say like which tests you can and can't do confidence intervals on. Just like list that out.
Which tests you can and can't do.
But it's up on the equation sheet.
Yeah, it is on the equation sheet.
Yeah, if you're gonna memorize the list that we got, then it's nice to know right next to it, you can't do it and you can't do it.
Okay, so you can't do anything that involves an F distribution.
So that includes ANOVA.
So ANOVA or, oh, no, I don't think we can do one on two. Yeah, we can't do it for two standard deviations either. Okay, you can't do it on, so F, you can do a hypothesis test on F, but you can't do a confidence interval on F.
You can do the Tukey test.
You can do the Tukey test, but that's not a confidence interval. The chi-square, the only confidence interval you can do on a chi-square is the 1 standard deviation. And then you can do them on the T's and on the Z's. So with the exception of the dependent proportion. The two proportion dependent, that one does not have a confidence interval on the Z test. I think all the other ones you can.
Are you filming right now?
Yes.
So for the chi-square, you said the only one that you can is the one population standard deviation.
Chi-squared is the only one population standard deviation you can do a confidence interval, but none of the others.
So for more than two populations,
You can do two. So you said more than two populations, so that's independence. You can't do you cannot do a confidence interval. We'd want to. You got more than two anyway. A lot of stuff.
Thank you.
And I think the only other one that you can't do is the Z two proportion dependent. You can do Z independent two proportion, but you can't do the dependent. I think that's right. But look at your formula sheet. That's the best answer. All right. So we're doing B3, Jaden?
Yeah.
Auto Magazine doing a price comparison on fuel prices. They've targeted 6 states they want to use for comparison. From a listing of all gas stations in each of the 6 states, they have randomly chosen between 40 and 50 in each state. They want to compare the average price of regular unleaded gas across the states, which hypothesis test. So, Mitch, is this categorical, quantitative, or regression?
It's quantitative.
Quantitative. Who agrees with him? Here, I'll write it down. Who agrees with Mitch? One. Mitch doesn't agree with Mitch?
Oh, yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Who disagrees? What do you think?
Categorical.
Categorical, what are the categories?
State.
No, those are the groups. Mitch was right. So we got 6 states we're comparing, but yeah, the price of gas is definitely a quantitative number. That's the main thing. We're measuring the price of gas, right? So that's definitely quantitative. Okay. Now what? What's the next question? Yeah, let's go with, you know what, last time we did that, it got us in trouble. Let's go with Z, T, chi-square, or F. I think that's a better second question. Okay. Who says it's a Z? Nobody? Who says it's a T? 1, 2, sort of 3. Who says it's a chi-square? 1, 2, 3, 4. Who says it's ANOVA? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think some of you voted twice. But we'll go with majority rules. It's the Oh, I said ANOVA, I meant F, but NF is ANOVA. Okay. Why is it, let's see, some people pick T. Why is it not a T? More than 2, right? Which is why it's the F. Why is it not a chi-square? Some of you pick chi-square. Because it's quantitative. So Caitlin was going to remind me to say something on camera, and she didn't remember to remind me.
I remember, but I didn't think, that you started the problem, I didn't think would be appropriate, but,
Oh,
with population, standard deviation, and proportions and stuff, how do you know which one's a categorical or quantitative? I can remind you.
that's not what you said before.
Well, this is.
You said, why didn't you just tell me this, is what you said.
Yeah.
So let's do that. And I like that you're speaking nice and loud. We might be able to hear you on the thing.
So I didn't, do you want me to say it?
Yeah, say
Okay,
it.
so why didn't you just say that mean and standard deviation is automatically quantitative, as well as the paired test? Slope is regressive and binomial proportion, independence, and goodness of fit.
You said it much more succinctly last time, but yeah. Why, so mean is always quantitative. Proportions are always categorical. Although chi-squares could be categorical too.
Standard deviation is always.
Standard deviation is always quantitative. And then, yes, and you said, why didn't you say that? I'm like,
Independence and goodness of fit are always categorical.
so chi-square goodness of fit is categorical, and so is the independence, always categorical. And I said, oh, well, I gave you that list, and I said that. But anyway, yeah, so there you go. So if you're measuring means, it's always quantitative. If you're measuring proportions or independence or chi-square, it's always categorical. If you're measuring standard deviation, it's always quantitative. And so that's why we ask, what were we measuring here? We weren't measuring the states, we were measuring the price of gas. Price of gas would be categorical. The states would be quantitative, or in this case, I wouldn't say, sorry, I said that. The price of gas would be quantitative. The states would, you could call it categorical, but really those are more of the groups. Comparing different groups' prices. Okay, does that make sense? All right, so you guys feel confident? No? What's your question?
So on this, if you were to change it and say like, we're gonna count the number of gas stations that sell gas between like the $3 to $3.49 range, like $3.50 to $4 range, like would that change it to a categorical test or is it still quantitative?
So you said you're going to count the number of gas stations in a state between 3 and 3.49 and 3.50 and 3.99. I don't know why you'd want to count them.
I don't know, I'm just curious if it would change it to categorical.
Yeah, that would probably change it to categorical. It would just be like, why are you doing that? But yeah, you could. Yeah, that would be, yeah. Yeah, sometimes math doesn't make sense, so that's why you do things that don't make sense. Okay? All right. So as far as rejecting, do not rejecting, do you guys want to skip all that? You just want to know what test to pick?
What are the null alternative hypotheses?
Oh, what's the only alternative hypothesis on this? All means are equal, at least one mean is different.
And you always want us to do a Tukey test, even if we find out that
Well, on the computer test, I want you to do it. Yeah, in real life, no, not necessarily, but I'm testing you guys, so.
So if you're saying,
There will be a Tukey test. I said that last week, didn't I? Yeah, there will be a Tukey test, there will be an ANOVA test, there will be a regression test. Absolutely. Beyond that, anything goes.
When are the circumstances when we should do a Tukey test?
When are the circumstances you should do a Tukey test?
for this class,
If you reject your null, right? In real
Is that
life,
only on chi-squared or is that on all tests?
ANOVA.
it's only on the ANOVA test. The Tukey only applies to the ANOVA test.
Because the
Okay.
Tukey test is what tells you which mean is.
You don't want us to reject and stuff, right? Because it doesn't get the p-value.
Yeah, well, I can make up a p-value and we can talk about that. Do you need practice on that, or do you want to just know the test?
No, I'm done.
Okay.
So ANOVA and on the test, we'll need to do it even if we don't reject the null? Or
Even if
only-
you don't reject the null, still do the Tukey test. The Tukey test should agree with why you didn't reject the null. There shouldn't be any differences, but I just want to make sure you can do the math. And I also don't want to give away the answer to the problem. Okay, yes.
Can we go with B4?
Before, no, after. In a blind taste test. That's your stupid dad joke of the day. All right. In a blind taste test, Alco wants to understand if there is a difference in the preference between 3 chewable vitamins among men and women. They select 146 men, 162 women. They allow each person to sample all 3 vitamins. For each individual, Alco records whether that person prefers brand A, B, or C. Alco wants to know if the preference is different for men than it is for women, which hypothesis test should they use. Okay? First question is, Marin? Quantitative, categorical, or regression, and it is categorical. What are the categories? No, those are the groups. Men and women are the groups. A, B, or C are the categories, okay? All right, now, which is it? Is it a Z, a T, a chi-square, or an F? Let's pick on Kendall. Z, who agrees that it's a Z test? 1. Who thinks it's a T? 1. Who thinks it's a chi-square? You changed your mind? 1, 2, 3, 4, 5, 6. Somebody voted twice, I think. Who thinks it's an F? Nobody thinks it's an F? Isn't there more than 2 in there? Okay, good. It's not an F. It is a chi-square. Which one? Test of independence. Okay. By the way, just FYI, in my last class, I've already posted the lecture. They love the goodness of fit test. I think some of you guys love the goodness of fit test. So there's an explanation in there. I won't repeat it, but go watch the video. And there's an explanation on when do you pick a goodness of fit? Because they would have guessed goodness of fit on this one. You guys were smart and said independence. Okay? All right. We don't care about the rest. What's your null and your alternative? Let's do that really quick. Preference is independent of gender. And your alternative, preference not independent of gender. Okay? Chris, is that what you said?
Yeah.
You agree? Everybody agree? Okay?
Can you do a box of screens and stuff?
Oh, that's good. Didn't we do that? Oh, I did that yesterday on the other class video. Did you watch it?
I didn't watch one.
Yeah. I can do it now if you want, or you can watch that.
If you did it on there, so I'm good.
Yeah. Okay. So yeah, I posted both class videos yesterday. So they did computer, you guys did scenarios. And today you're both doing scenarios. So
Can we do QQ plot?
I did that yesterday on the video as well.
There's-
On their video.
Geez, they're asking all big questions.
I know, they're asking the good ones. All right. What else do you got? Do you want any other questions? Histograms? Anybody remember how to create the histograms properly?
Yeah, that's right.
I already went through that.
Well, you can't use the histogram maker. That's crap anyway. Not hard. Okay. All right. What else?
C4.
Would you say C4? Are you going for all the ANOVA ones here? Or the?
Is that an ANOVA?
I don't know. I haven't read it yet. I was just wondering if that was kind of your thing. All right. Totonic Chemical Maker is a maker of organic pesticides. They've been working on some new products. Recently developed a new mosquito repellent. They want to test it against the most popular brand. They've lined up 42 volunteers. Each volunteer is provided with a spacesuit that completely protects their entire body but leaves their arms exposed. volunteer for that. Leaves from the elbows to the tips of fingers. Each volunteer is sprayed. So usually that's not what they do. They don't give you a spacesuit. What they do is they have a cage, like an aquarium, and then you stick your arm in the aquarium. Anyway, I don't usually do the spacesuit, but that's fine. Okay. Let's see here. Each volunteer is sprayed on the arms with repellent, the popular brand on one arm, the new product on the other. They're introduced to a mosquito cage where they spend about 4 minutes purposely exposing their arms to swarms of mosquitoes. Like, who in their right mind would do this? They must pay a lot of money for this. After exiting the cage, each volunteer waits 2 hours and examined closely by a dermatologist to count the number of mosquito bites on each arm. The counts are tallied and recorded on the table. Totonic wants to compare the effectiveness of the two products. Which hypothesis test should they use? Here, let's put this all on one page so that you don't have to scroll. All right. So, what's the first question, Gabriel? Okay, and what do you think? You think it's quantitative? Who agrees with Gabriel that it's quantitative? 1, 2, did you raise your hand? 1, 2, 3, 4, 5, 6, 7, 8, 9. Who thinks it's categorical? 1, 2, 3. What are the categories? 4.
Works or doesn't.
Yeah, works and doesn't work.
Oh, I thought we were counting the number of bites. Are we counting bites?
Oh,
No.
well, but then,
It's a paired
Once you compare the effective,
Well, how do you know the mosquito repellent is effective? Did you get bit or did you not get bit?
0 bites would be effective.
And we're counting, this one has 20 bites and this one only has 2. Which one works better? The 2 works better, right? Okay. So Gabriel was right. It's quantitative. We're counting bites, aren't we?
Yes.
Yes. Counting bites. So it's quantitative. Okay. All right. Now, Z, T, chi-square, or F. If you got the first part wrong, you're screwed here, right? Okay, who says it's a Z? Nobody. Who says it's a T? 1, 2, 3, 4, 5, 6, 7. We got almost everybody. Who says it's a chi-square? No curmudgeon in the room. F. Okay, it's a T. What kind of a T is it?
a paired team.
Paired T. Who thinks it's something else? Nobody? Okay, paired T is correct. What's your null hypothesis? What did you say? Did you say D1 equals D2?
No.
Mu1 equals mu2? Who agrees?
No, I know that's wrong. So don't make
Only Adam agrees? Is that a raised hand? Who disagrees? Spencer, what is it? D equals 0, that's correct. Paired t-test is always D equals 0. Or mu sub D equals 0 if you want to be super good. But I can't write a mu on my paper very well, or my computer very well. Okay? Feeling good about that? Christopher?
How do we know that it's a paired T-test? Like, what
How do we know that's a paired t-test?
person.
What'd you say?
The same person.
So it's
The
just
same
gonna be
person.
dependent?
One mosquito repellent on one arm, one mosquito repellent on the other arms. Walk into the
So-
cage,
so
get
because
bit.
So you do the paired one, it's like a dependent T-test?
It's a dependent t-test. Yeah, paired, that's another word. Paired test is a dependent t-test because it depends on the person. Okay? Have you ever heard that bananas, let's see, they attract mosquitoes? I think they attract mosquitoes. If you eat bananas, they like bananas. And they will, I don't know if that's true. I've heard that. Yeah, but they like the banana in your blood. I don't know. I've heard that.
you do a quick speed like one.
Speed, we got a 1 minute left. Which one do you want me to speed through? D3?
Short one.
D3, a short one. Medical research is trying to understand if 4 topical anesthetics are being used in the same ratio in 3 different clinics. They have access to the medical records over the past 3 years and have recorded each treatment. Using a tally sheet, they have determined how many times each antiseptic was used at the 3 clinics, and they want to compare usage across the 3. Which hypothesis test? Okay, what do you guys think? Categorical or quantitative or regression? It's actually categorical. Okay. Which kind of a test? Chi-square independence. Okay, we're doing that quickly. Now, a lot of people would have thought ANOVA. How many people thought ANOVA? Nobody? ANOVA looks like it because you're thinking, oh, these are antiseptics being used. So the key questions here, ANOVA, okay, you're going to compare mu1 equals mu2 equals mu3 equals mu4, right? That's normally what you would do with the ANOVA. But the problem is we're comparing antiseptic 1, 2, 3, and 4 with clinic 1, 2, and 3. So you're going to have a table that's going to look like this, okay? The ANOVA is only going to be like a single row of means, okay?
So pretty much because there's multiple groups.
Because there's
testing
multiple
different
groups,
samples.
and plus they're doing the tally sheet, they're just going to say, oh, they're using it here, and 1, 2, 3, 4, 5, and whatever. They're just doing counts at each clinic. Okay, so yeah, the independence test is probably going to be, in this case, a 3 by 4, whereas the ANOVA test is just going to be 4 means. Okay. All right, that was a good one. Okay, see you all tomorrow.